In this code.org lesson, we are learning code. All right, we're going to look into some of the foundations of computer science. Let's go. That's what we're doing. Run the simulation 5 times. Each time, use the collecting data activity guide to record how many apples did the elephant collect, how many apples did the hippo collect, how much time did it take for all the apples to be collected. Awesome. And my student should already have this document. You might have it paper or digitally, but that's where we're going to record. So run 1. We need to know how many apples did the elephant collect. Let me hit run. Okay, and so here's the information I need. 9 for my elephant, 11 for my hippo, 23 seconds. Now let me hit back over here and let's do it again. I'm going to have this sped up some, and we'll talk about it at the end. All right, and here's my data, right? Elephant 9, 10, 1, 5, 11. So it varies a lot. Hippo 11, 10, 19, 15, 9. And of course, yours is extraordinarily likely to be different than mine. It'd be very strange to be exact. 23, 7, 10, 19 seconds, and 7 seconds. All right, now let's see what we're doing. Use a different color for each animal. Draw a line graph that tracks how many apples each animal collected during the 5 simulations. And is this... Since I'm doing this digitally, I'm going to click on this image and then right click, and I'm going to say copy. Let me, if I can now insert drawing, new. I'm going to hit paste, and this is how I'm going to be able to input my data. So it's going to take me a second. Elephant is blue. So elephant is 9, 10, 1, 5, 11. I'm going to copy that guy, and I'm just going to move this around. So 9-ish. Do the best I can here. 10. 1. 5, I believe. And 11. 9, 10, 1, 5, 11. Great. Hippo is 11, 10, 19, 15, 9. 11, 10, 19, 15, 9. Hippo should be red. Actually, I'll just copy this. You could use Control C and Control V as well, or Command red for this one. Since they're both here, I'll just kind of sit them next to each other. 11, 10, 19, 15, 9. That would make more sense since that was 9. 11, 10, 15, 9. Yeah, an easy way to double check is that it would add up to 20. Okay. Probably be a whole lot easier to do this on paper. But, oh no. Alright, that was a bit annoying, but we got it. Okay, we got that one. Modify and predict. Now that you have some data about the simulation, it's time to start experimenting. On the second bubble of this lesson, you will be able to modify the variable, alright, so we're using variables, that control the simulation. Pick a variable to change and predict how that will change the data. So variables, keep in mind, like X and Y are, it's items used to mean something else. So in math, you might see X plus 3 equals 4. Okay, so then what would X equal? Well, then we must know X equals 1. So it's a value, it's an item that's in place of something else. It's representing a different value. Okay, so we got the experiment, finish, continue. All right, modify and predict. So I'm going to start by modifying the elephant's speed. So predict the outcome. Of course, make sure you're using your own words, and we could have done anything. I'm increasing the elephant speed. Maybe you want to decrease the hippo speed. What if the hippo moves slower than the elephant? Or maybe you want to increase the amount of items collecting. So if the hippo is slower than the elephant, I don't know, maybe the elephant will collect more. Or maybe you want to increase the hippo, so on average it will have even more. increase the collecting, that will just be the amount they gather, but it depends on time. So anyways, this is what I have. I will increase the elephant speed to be more than the hippos. I predict the elephant will gather more apples on average than the hippo, and we're collecting the data again. So let me go ahead and I'm going to put mine up to like something crazy like 10, and boom. 14, 6. And like before, I won't make you sit through this. I'll speed it up. Something I maybe should have guessed is that I bet there's a shorter time as well. But let me go through this and I'll talk at the end. Alright, and it looks like my guess was pretty good here. Almost always the elephant has a whole bunch more than the hippo this time. Visualize your data. Choose a way to visualize the data collected to see if your prediction was accurate. So I'm actually going to use a chart similar to what we just did. So I'm going to copy this drawing, and I'll go down here and paste it. Now this time I could put the hippo as well, but I'm going to focus on the elephant. So let me go ahead and edit this guy, elephant, and then I'm just gonna faster elephant. I could put elephant with a speed of 10. I highlight it with white, I should be able to hide hippo. I could make it gray too, but I'm fine with how that looks. Okay, now I need to get this data. So let me see real quick. So 14, 7, 12. Okay, let me get that on here. Oops, I should keep the blue because that was the last performance. I'm going to move the red because I'll use that for the faster elephant. Cool. So you can really see it impacting or changing up that speed of my elephant, that variable that was representing speed, the red being faster. It always, other than one time, is much faster. And on average, or collects many more things. And on average, right, it's pretty high above, not just a few. So that really helps us see how these variables impact the program as a whole and how quickly you can really change the dynamics of a program just by changing one item. So we certainly could have changed other stuff here, and that would have also impacted it. So keep in mind how easy it is to use variables. One, we know if this variable is named speed, it's pretty easy to understand what it will be doing. And two, it's going to have an impact in your program depending on how it's used throughout. So what you really just want to remember is a variable is used to represent something else. In this case, numbers. Cool. Onward.